All right, so we got this Heathkit Model T3 signal tracer all put back together. Recap, here's all the casualties. Had these 4 electrolytics, 2 at 20, or 2 20s at 450 volts and 2 10s at 450 volts. Got those changed out. 5.01 microfarads and 4.1 microfarads. These are 0.05, excuse me. These are the big ones are 0.05 and these are 0.01s. So got all those changed out. We're going to bring this thing up on the Variac and current limiter and see what it does. Let's try it. Okay, we're sitting at about 70 volts, drawing about 40 milliamps. So far, so good. About 80 volts, 50 milliamps. Should start seeing this thing kind of come to life here, maybe. At 80 volts, I think. Yep, there you go. There you see the magic eye tube kind of glowing. All right, let me get these caps out of the way. Over there on the breadboard. Okay, here we go. Up to 90 volts, 80 milliamps. Coming alive, coming alive. Ooh. Okay, we got a really scratchy pot here. I haven't put the screws back in this thing, so I'll go back in there and I'll clean this up. What I did is I took this mic connector off of here for the RF probe, and I stuck a little 1/4-inch jack here, so you just use a 1/4-inch jack. I was going to put a BNC there, but when we test this here in a little bit, I'm just going to use the audio side because I haven't yet built an RF probe, so we're going to use the audio side to see how this thing works. But I'll tell you right now, it's got a lot of gain. I got to get that pot cleaned up. Okay, so let's keep going here. 100 volts, drawing about 90 milliamps. See that on there? 80 milliamps. Okay. And let's go up to 120 volts. Something like that. 114 volts. Drawing 100 milliamps. Okay. All right. The magic eye works. Everything looks good. I'm going to go ahead and take the power down on this thing and clean up that pot, and then we'll see what it acts like after that. All right, I got this thing, be right back, cleaned up a little bit. It's much quieter now. There's still a little bit of hum. I think it's maybe some 60 hertz hum. So I'll check the lead dressing. I may have a bad tube. One of these tubes may be bad. I didn't test any of the tubes, but I'll look at that. Let's put a signal on this thing and see what it sounds like. All right, so that's at 30% gain. I got a 1 kilohertz cycle on here, 1 kilohertz signal on here. You can tell it's got quite a bit of gain, but that hum's starting to come through. So, and also the magic eye doesn't seem to be working. So, yeah. It doesn't seem to be deflecting at all. So I've got to troubleshoot that. this pot here is kind of sensitive as well. But it is working. I just have a few little things to fix on it, and build another probe for the RF section, which requires a demodulator circuit in it in order to take the RF out, so that you're only amplifying the audio. Figure out why this Magic Eye tube is not working, and test these tubes out. I may end up having to replace the tubes, but it is working. So okay, so I got this thing much quieter now, but I do have a problem still. A couple of problems actually. First thing, I found out that this 12C6 here, or 12C8 is what it is. It's not marked as a 12C8 on the tube, but that's what it is. It was introducing a lot of 60 hertz hum into the circuit, and as soon as I pulled it out, that went away. So I'm going to put this on the tube tester, but if this was just a matter of getting another gain stage, I would probably see if I could find a replacement. But this tube is also used for the watt meter. It's got two plates right here, basically like a diode, that goes down here to the wiper of the transformer for the watt meter load. So basically, you plug something in here across the 120 line. Whatever current it draws is going to have a proportional voltage across this winding. This is going to translate to this, and then that's going to basically translate into opening and closing the eye circuit up here, the eye tube, right? So anyway, I haven't got that far with that yet, but I have got this thing quiet down quite a bit. This is all the way up on the gain, with just the audio input gain stage in. But I've got these artifacts in here. You hear that? And what I found, and this is kind of the same thing that Mr. Carlson found on his video, is some of these carbon comp resistors. Let me get this thing turned around here where you can see this better. Some of these carbon comp resistors get bad, and they introduce a lot of noise. So this one right here, I've got a problem. I've already changed out some of these carbon comps because they were out of spec. So I got a couple of them right there. Completely recapped everything. I still got some carbon comps in here that are, this isn't the power supply circuit. But anyway, if you look at this one right here, you can hear it. It's very noisy. So I'm going to change that out, and we'll see what we got with that. Okay, so I replaced that resistor. and no more crackly poppity. Nothing. So I'm happy with that. So I need to find a new 12C8 tube. It's a tetrode preamp, and then it's got these extra diodes on the side here. They're tied together. So yeah, this may be hard to find in an octal tube. I've seen this type of tube in a 9-pin tube, this type of configuration. I forget what it was. It was a 6 something, I think. I may even have one of those. But if I can find one of these, that'd be great. If you guys know where one is, or if you have one, you want to shoot my way, that'd be great. But this thing's up and running. When I get this tube, when I get the replacement for this tube, I'll make another video testing out the watt meter, and maybe we'll do something with the B plus on here, and maybe even put it on a radio and trace out the signal. But until next time, thanks for watching.